Hello, everyone. I'm Sarah Jennings with the Frontier Development Lab, and welcome to today's SETI Live. I'm here today with one of our FDL teams, which is the Lunar team, and this challenge is in partnership with the Luxembourg Space Agency. So today I am joined by Paula, Jose, and Miguel. And I would love if you guys would be able to introduce us to the challenge that you're working on and why it's important.
For sure. Thank you, Sarah. Hi, everyone here in the conversation and at home. I'm really excited to be here. I'm also, as you can see. Yeah, I'm going to start the presentation, a little presentation on why we are doing this, like what is this lunar challenge that we are doing here at FDL. And I'm going to do this presentation with my teammate, Paula. We are both of the researchers of this team, and Miguel here is one of our mentors. So, okay, so the first thing that you may be wondering is like, why we are talking about the moon? I mean, isn't Mars the next target for agencies and companies? And I really like to share always like this slide from the Artemis team from NASA. That is, so it's humanity is returning to the moon. And yeah, so basically the moon is on the scope again for agencies and companies all over the world, and it's the next target. So there are like some upcoming missions that will happen in the next few years. There have been some missions that happened in the last few years, and this time all the programs and missions that are happening doesn't have like just the objective of just being there for some time and just come back. We like actually the programs like Artemis are targeting establish a permanent presence on the moon. So I think that this is fascinating, and this is why we are aiming to work on the moon. So in order to establish this permanent basis there is something key that is missing right now, that is water. So when we're talking about the moon as any other place, we need water to establish this type of presence basis and everything. And in the moon, we have the biggest concentration of water at the poles. So something that I find always really interesting is that at the poles, there are some areas that are called permanently shadowed regions that, due to the lighting conditions that you can find there, have like the cold, these regions are the coldest place in this whole solar system. So it's not on Pluto, it's not like at the end of the solar system. These regions here in our moon are like the coldest places there, and they also are acting like a cold trap for the ice that are there. So find this always like really interesting, and this is why in our challenge we are targeting this polar region, especially the South Pole, because the next upcoming mission that we can see here, an example, the NASA's Piper, is targeting the South Pole as the objective of the mission. And in order to prepare this type of mission, one of the key resources are the images, and this is what we are working with in our challenge. And now I'm going to let my teammate Paula introduce give a quick overview of what we're doing here at FDL.
So hi from my side, I'm Paula. So thanks, Jose, for introducing why we're interested in the moon and why we're interested especially in the South Pole. So like Jose said, we need, in order to prepare for missions, we need images of the lunar surface. And I'm going to now talk about what we're actually gonna do with those images. So you can see here, this is a projection of the lunar South Pole. And looking at the left-hand side, we have plotted all the images we have available for the South Pole. So each image is a blue dot. And you can see here that close to the pole, there's the blue is denser. So there are a lot of images because we especially are interested in this region. And there's also images all over the place. And this left-hand side image corresponds to the blue histogram here in the middle. What you can see here is the number of images for each resolution. So you can see we span like from half a meter resolution per pixel up to 2 meters, and we have all this distribution. If we now only look at the right-hand side, where we have images which have high resolution, so better than 0.8 meter per pixel, we suddenly see we lack in images at the pole. So where we're especially interested in, we don't have really good quality images. And you can see, so this orange, this right-hand side image corresponds to the orange distribution in the middle plot. So what we want to do, we want to have also high resolution images directly at the pole in order to be able to plan our missions there well. So how do we benefit of higher resolution image? Here's an example. You see here an image which has about 1 meter per pixel resolution, and it's kind of blurry. So if you look here, if we want to plan a trajectory for a rover, we're not sure, are there craters, are there not craters, where can we go? But we want to plan, so we want to have that information. So that's where we want to come in, and we want to go from this blurry image to this image with much more details, which is half a meter per pixel resolution. And suddenly we can see, okay, we do have those craters here, and we're going to avoid them and safely steer our rover towards some sort of target. So what we want to do is super resolution, going from the upper image to the lower one. So using the low resolution images at the pole and increase their resolution. So going back to Sarah's question, why is it important? So one thing is safely steer a rover, but there are other application cases which are in the scope for upcoming missions. For example, better finding resources on the moon, or finding good landing sites. So yeah, that was our introduction to our challenge.
Awesome. Thank you so much, Jose and Paula. So what I got from that is we're going back to the moon. Water's really important. In order to be able to navigate the future missions of the South Pole, we're going to have a better understanding of what the South Pole looks like. So you guys are taking a look at these images, and you showed us an example and mentioned super resolution. Can you talk a little bit more about what that is and how you're using that technique with the images that you have?
Okay, let me take this question. So some of you may know shows like CSI, where they have some sort of image or video, and really small in the image there's a tiny side mirror of a car, and then they say zoom. So they zoom in to this tiny side mirror, and you just see a bunch of pixels there. And then they say enhance, and suddenly you see a reflection of a face in the side mirror, and you can even identify this person. So they get out of a few pixels, they get a high resolution face image. And yeah, this is magical, and this is not realistic, but we want to do it. We want to do it as well, but in a realistic way. So it's actually let me show a slide again for that. So it's actually a classic topic in computer vision, super resolution. And what it would look like for us would be, okay, we have this low resolution image, which you can see here on the left-hand side. And we maybe want to just double the resolution. And then we want to get to the right-hand side. And the way we would do that is not with classical computer vision methods, but with machine learning. And that would mean we would have pairs of high-res and low-res images. And then we would train a so-called artificial neural network on it to learn the patterns in the low resolution, which patterns in the low resolution images correspond to which patterns in the high resolution images. And so we would learn the pattern, and then we would be able to, if we get new low resolution images, where we don't have the high resolution counterpart to be able to create a super resolved image. And yeah, that's what we're aiming for.
Great. That's an awesome explanation, Paula. And I love that your backgrounds, they also seem to be super resolving as well. So thank you. And it looks like we have people joining in from all over. So I just want to do a quick shout out. We've got people from Spain, Norway, New Zealand, Toronto, Michigan, Mexico, Boston, Luxembourg. So welcome and thanks for viewing. So Paula, you had talked a little bit about some of these images that you're using. Can you talk about those images a little bit more and what missions those are coming from?
Yeah, I mean, I can explain a little bit what we are using for this project. So basically, there has been some missions that had the objective of gathering images from the lunar surface, but in our case, we are mostly focusing on NASA's mission. There is a mission that is called Lunar Reconnaissance Orbiter (LRO), and this is a mission that has been going on for the past 12 years, gathering information about the moon, not only images, but also like all types of information and data by using different instrumentation. Of course, as we are like talking about images, I'm going to focus on that. Again, there has been like some other missions, but NASA's Lunar Reconnaissance Orbiter is a mission that was able to gather information about like the 98% of the whole surface of the moon. So this is why we are trying to use this set of images and why we are focusing on improving them. Also, there is another mission that we will be using in our challenge. That is the Chandrayaan-2 mission from the Indian agency. This is as there are not that many high resolution images available from this mission, we are only going to use it for the validation part to prove that our solution is working nicely. But yeah, our main focus will be NASA's LRO dataset.
Great. Thank you very much for sharing that with us. So I also want to ask the audience, if you have questions, please feel free to share those with us. We'll have time, hopefully at the end, to take a couple of those. But now I want to hear from Miguel and hear a little bit more about Luxembourg's vision and aspirations for this challenge, and anything that you want to speak to in general about the future of space exploration with Luxembourg.
Hello, Sarah. So thank you very much. Yeah, yes, in fact, Luxembourg is one of the pioneers countries in the world that is focusing on space resources. So they are attracting many companies around the world in order to create an ecosystem here in Luxembourg in order to work on the space resources. Yeah. That's the idea. Basically, the idea is that in order to go beyond in this space race that is getting more and more exciting with the inclusion of many different companies, then we will need to use the space resources. Yeah, we need to find them, to extract them, and then to use it in a space. Yeah, that will open us many different possibilities. For example, going beyond the moon or going to Mars. Yeah, but especially Luxembourg is focusing on the use of the space resources based on the history of the been working on mining industry for a very long time. Yeah, so the idea of Luxembourg is to create this ecosystem here in the country with the different companies collaborating or working together, and also in relation with in collaboration with the university and the research center. So then, yeah, we are of course working with ESA, so the European Space Agency, LSA, so the Luxembourg Space Agency, also working with NASA, signing the agreement for Artemis program, and is in collaboration with other space agencies like the DLR in Germany, the British Space Agency, the Indian and Japanese, for naming some of them. Yeah.
Great. Thank you, Miguel, for providing those insights. It's all very exciting what we're doing with lunar exploration and beyond. So I wanted to ask each of you why you are personally interested in this challenge. So I don't know if one of you would like to start.
Yeah, I can start. So what I really like about the challenge is first the moon. So the moon was always really fascinating for me and something I would look up to. But working with all of those images, it's almost like being on the moon and exploring, which is great. So I love that, and also it's really great to work in like interdisciplinary, to have machine learning, have space science, and put that together and apply the algorithms to problems which are useful, which are gonna have real world impact. That's very satisfying. And,
Great to hear. Thank you so much, Paula. Jose, Miguel?
I can go. Yeah, I mean, there are like many things that I really like about the challenge. So one of them, like being able to connect with so many people from so many disciplines. Like as Paula said, like we're mixing like a lot of disciplines here, like a lot of fields of research, but also like there are like many people that are participating in this from everywhere, all around the world, and that's amazing to be able to connect with them and work with them. Like if we focus more in the scientific part of the challenge, I will say that being able to do research in space is always amazing, but also like having the opportunity of talking with people from NASA, for example, from experts, with talking with experts in the fields, and like having the remote possibility of like using this solution to contribute a little bit to any of like these potential missions or the missions that will be happening in the upcoming years. For me, it's like it's mind-blowing. I mean, I'm still like I don't believe that I am still participating in this, and I find it fascinating. So yeah, I think that's it.
So I get just as excited about as you do about working on these lunar projects. And Miguel.
Okay, so well, that's this is my second year participating in this FDL with NASA and SETI Institute. So what I can say, where is a kid that never dreamed to work on NASA or to be connected to any kind of NASA activity? That's everybody, yeah, in the childhood have dream about that. Then after the first year, I was, of course, now addicted to this. Yeah, FDL, NASA, the SETI Institute, all the good insights that are given by the experts of NASA that are always finding time in order to show us what they are developing, what they are doing. Unfortunately, with the remote mode is not that exciting because we cannot visit the facilities. But anyway, is amazing. Yeah, people working in FDL, NASA, and SETI program are absolutely the top in the world. So it's always great to get insights with comments and discussion with them. Absolutely, it's amazing. Yeah.
Yeah, I love the network and all of the support. So with this particular project, it's with Luxembourg, it's with Google Cloud. We've had lots of interactions with NASA and some of the previous researchers from last year, Ben and Valentine. And then you guys have also gotten support from Oxford with Yaren and Freddie and Mo. So it's just been this really great culmination of people that we've been able to work with on this lunar one. So it's really exciting. So it looks like we are getting a few questions in. So if you do want to ask us questions, please feel free to do so. And thanks for joining us. It looks like we've got people now from Arizona, which is where I grew up, Romania, Puerto Rico, England. So thank you all for joining. I'm going to ask the researchers and our lead here one last question, and then we'll dive into some from the audience if we have time. I just wanted to actually ask if you had any last thoughts for the audience to take away about the work that you're doing this summer.
Yeah, I mean, I was thinking that about something to say to the audience directly, not only about our job, but like space, our like the research in general. And I feel like space is such an interesting research topic, and I think that is the field that can make people come together and just push forward to get to many different places and have like achieve like amazing goals. So I feel like for people that are like thinking about like going to space, working in the space as a field, I think that this is something that you have to, because it's amazing. And for people that are not that don't like research that much, or there is just like spectators in the whole thing, I think that something is great is coming. Something great is coming for sure in the next few years with all the missions that will be happening. So stay tuned, because I'm pretty sure that it's going to be amazing.
Thanks, Jose. Paula or Miguel, do you have any last things to share before we dive into the questions? Nope. All right. You agree with Jose. Space is exciting, and we're looking forward to the future lunar missions. Awesome. So speaking of lunar missions, we have a question. What is the primary mission of the South Polar Lunar region?
Yeah, so in 2023, the Viper mission is happening, and this is a NASA mission that will put a rover in the South Pole, where basically this mobile robot is going to explore the region, and is like the objective is getting a close-up view of the actual location, like diving even into the crater, looking for this water ice that we were mentioning before, in order to evaluate the concentration that it's out there, and like giving us really valuable data in order to plan future missions that could potentially have the aim of extracting this water ice and utilizing it for like sustaining life of astronauts that are up there, or even using it as a rocket fuel for when we are using the moon as a stepping stone to go to Mars or other places.
Great. Thank you for providing that context. That's really helpful. So I will go ahead and take one more question here about what is something that's interesting about the moon that one day we might be able to solve or know the answer to. Or, I mean, I'll even expand it if there's something that you think would be really interesting to be able to do on the moon. So any of those things, if anybody wants to kind of share your thoughts.
Well, I can take that one. Yeah. So yeah, the idea is that we can do many amazing things there. Yeah, on the moon. So just see what how many experiments have been done and information that was gathered in this experiment have been used on Earth. So I'm talking about the ISS. Yeah. So we managed to do many experiments over there. And if we manage to have a lunar base, that's we will extend incredibly all these experiments, and we can go beyond many problems that are still unsolved on the moon, on Earth. Yeah. So, for example, there are other teams in FDL that are working on radiation and shield, and also all the problems with cancer. So that's just one of the things that we can do over there. But well, that's basically the most important on regarding the extraction of water ice, is to be able to do fuel propellant for the spacecraft, as Jose has mentioned. Yeah. So I would say the possibilities are immense. There are many of them, and we are looking forward to see this mission going there and starting to do amazing things.
Thanks, Miguel. Paula and Jose, Jose, do you want to go ahead?
Yeah, I mute myself first. Well, I just wanted to say that I totally agree with Miguel. This is the first thing that I came to mind when I like when you said the question, Sarah. I really love when scientists come together to do great things, and I think that like having a base on the moon, as it happened on the International Space Station, is that what it's going to happen. Just like a lot of exciting experiments, something that can be really useful for humanity itself, and having this, and also like some other idea that is really exciting to me is the like having a so-called gas station on the moon, like having a rocket launcher there, like the moon being a place where you can just land the rocket, refuel it, and then launch it to other places of the solar system. This is something that is crazy, but nowadays it doesn't seem to that far away as it could have appeared before. So I'm pretty excited about all of this.
Thanks, Jose. Yes, lots and lots of possibilities. Paula, is there anything that you wanted to share about interesting things that could potentially be uncovered or happen on the moon?
I mean, I come more from the machine learning side, so I'm still exploring the moon myself. I'm sure there are a lot of exciting things, but yeah, nothing to add from my side.
Awesome. Yes, lots of mysteries to uncover still. Great. Well, this has been really, really wonderful. Miguel, Jose, and Paula, learning about the lunar work that you're doing. So I think we'll go ahead and end there. But I wanted to say thank you to our audience for taking the time to listen to us. And we'll be back with the Frontier Development Lab on a SETI Live tomorrow with the digital twin of the COAST team. So thank you all.
Thank you so much.
Thanks.
Thank you very much.